start doing robotics when we went to my sister's high school robotics competition. We were super interested and we really wanted to learn more.
We've been doing robotics together for 4 very fun years together. Our first year of Robofest, we did a competition called Robogolf, which was a robot that could cut balls into putting holes. We learned a lot about basic building and basic programming that year. Our second year, we did a competition called RoboHit, which was a T-ball hitting robot. And we learned a lot about strategy that year.
The same year, we also made a CNC cookie frosting machine. We learned a lot about math, and we also learned how machines are used in real-life applications. The year after, we made an aquaponics system, and we learned how to use Arduino, which was completely different from anything else we've done. And this year, we did the binary block challenge, where we really cemented everything we learned and dove in even deeper to the stuff that we just grazed the surface of. Now, the rules of binary blocks were pretty simple. We had to have a fully autonomous robot, which means we couldn't use it with remote control, and everything had to be pre-programmed. We also had to make a binary number from the boxes. So we had each slot representing 1, 2, 4, and 8, where the white boxes had a value of 1 and the blue boxes had a value of 0. So for example, we have 1, 0, 0, 0, where the 1 is in the 1 slot, so the value of the number is 1. Say if I put it here, this 1 is now in the 2 spot, giving it a value of 2. Can anyone tell me what this number is? That's right, it's 3. Because we have a 1 in the 1 spot and a 1 in the 2 spot, so you add them together and you get the value of 3. We also had to put stacks in the most significant bit. So we get a certain color, in this case it would either be white and blue. If we got, say, white, we would put a stack on the most significant bit, so the highest bit with that value. If we had a blue stack, we would put it over here since that's the highest value where there's a blue block. We also had to load from the start zone, so we can only touch a robot when it's in this spot. Anywhere else, it relied purely on the programming. After we made all our stacks, we had to do an unknown end task, which could be stopping on a certain edge, or maybe even stacking extra blocks. And we only had 2 minutes to do all of this, so we had to make sure that our robot was fast, but still accurate.
So now I'm going to talk about how we structured and built our robot. So we needed to make it the right size to fit into the slot and to release the boxes without hitting all the other blocks. We also needed no tangled wires so that we could easily access the brain of the robot called the EV3. We created gripper designs so that they could hold on easily without dropping them. We have a consistent funnel. We have a consistent funnel here so that when the robot grabs it, it doesn't go sideways, it goes in. We also have a consistent stack, so when we stop loading the block, it'll sort of wiggle the boxes into place, and it'll be like a perfect stack.
So we started off with a mostly Lego robot, but we realized that Legos weren't really the best for some of the specific tasks we needed. So as time went along and we realized we can make better parts, we would design 3D printed parts in SolidWorks, then send them to our team's 3D printer using Shriya, and then we would print the pieces. We made sure they were Lego compatible so we could still use the parts that were working. But it just gave us more versatility and it made our robot look really cool. Now over our 4 years,
cool.
Oh, very cool, yeah. Over our 4 years, we learned the basics of what every robot needed to be able to move. First of all was being able to drive straight, so you could get around the table. We had to use math to convert rotations into degrees and into distance to see how far one rotation would get us, or how many rotations we need to go 5 inches. We also need to learn how to turn, again, making sure our turns are very precise and accurate, so going from rotation to degrees and using a lot of math in the process. We also need to be able to line follow, say on the edge of the table or on these black lines. We made sure that our light sensors were always consistent and made sure that we had good readings. We also need to be aligned on the edge to make sure that we're perfectly square before turning or pushing or blocking. We usually do this twice just to be very accurate, and you'll see it a bunch in our demo.
So these are just really the basic building blocks to a program. So some of the routines that we have are like turning left or driving until an edge, and we don't want to like copy and paste this like 1,000 times in a program. So we have my blocks, which are just one block and can represent multiple blocks. In the part of our program, we created a part called initialize, which we could put in all the variables. So this is D5 and D6, or D5 and D6, and they're the distances from where the block is to the black line. And so we could plug it into initialize so that the robot knew exactly where to clamp the grippers and not go any farther to waste time. So we could also put like light sensor values there or speeds there as well. So we also had a homing routine so that the robot knew like where it started exactly, and it knows that it's in the home base.
Now, to get all this right, we had to do a bunch of testing. Whether it was testing the light values or a gripper design. Like before, our grippers used to slide up and down, but we put multiple sets of grippers to make it way faster. And this took a lot of time, a lot of trial and error, but it was all worth it in the end. Now we're going to demonstrate one of our programs. And since 9/11 was very recent, we wanted to make a new program as almost a tribute to that. So this is our Twin Towers routine.
And do you have any questions while we set up the table that we might be able to answer?
How many?
Oh, one over here.
What grade are you guys in?
I'm in 9th grade and she's in 8th grade.
How many weeks have you worked on this before World Championship? Around.
It was
From like
Oh yeah.
Yeah, it took several months and our robot went through a lot of changes. So it was a lot of time and a lot of work.
How did you get into 3D printing?
Well, Maria actually has a 3D printer at home and
I was gonna ask, like, how did you? That is so cool. Okay.
Yeah.
I really like 3D printing because we both like 3D printing because we can like design like anything you want.
Yeah.
So we didn't even just use stuff for the robot. We have like a really cool pair of like 3D printed glasses and stuff. It's really fun messing
course.
around and learning all the possibilities.
Super. Thank you.